Hey guys, so I thought I would kind of conclude this unit. I just kind of went through your textbook, guys, and I kind of found some of the word problems that students of mine have. I know that they've found difficult in the past. So I thought I'd just go ahead and walk you through how to do some of these word problems, and then I'll leave it to you to go and practice some more on your own. All right. First one, page 230 from question 12. An osprey, a fish-eating bird of prey, dives toward the water to catch a salmon. Its dive can be approximated by the function h of t is 5t squared minus 30t plus 45. Determine the time it takes for the osprey to reach a height of 20 meters. Okay. All right, so what we have here, we have h equals 5t squared minus 30t plus 45. And what happens is we're going to take this 20 and we're going to put it in for the height. So that means 20 equals 5t squared minus 30t plus 45. So for quadratic equations, we always want to set one side equal to 0. So I'm going to subtract 20 from both sides like this. That's 25. And now I'm going to factor this one. Now I'm going to solve this one by factoring. So before I do that, I can just take out a common factor of 5 here. So we have 5t squared minus 6t plus 5. And that means 0 equals 5. And then we get t minus 1, t minus 5. So we get t minus 1 equals 0. That means t equals 1. Or t minus 5 equals 0. And that means t equals 5. All right. So the question is, the osprey will be at 20 meters at 1 second and 5 seconds. And that makes sense why there's two answers, right? Because if he swoops down, he'll be 20 meters, and he starts coming back up, he's going to be at 20 meters again, right? So that's why there's two solutions here. All right, there's question. First one. Page 231, question 17. A rectangle with an area of 35 centimeters is formed by cutting off strips of equal width to form a rectangular piece of paper. What is the width of each strip? Okay, so what it's saying over here is that this area is 35. There's a pink area in here, and we have this guy over here. Okay, so I think a way we can do this is, like, you see we have an x here and an x here and a length of 7 there. That means that this length is going to be, well, it's this whole length minus this x and this x over here. So it's going to be 7 minus 2x. And then this width over here, well, it's going to be 9, but then we're cutting off an x here and cutting off an x here. So this part's going to be 9 minus 2x. So I'm just going to rewrite this over here. Well, we have 9 minus 2x and 7 minus 2x, and we know the area is 35. So the area of a rectangle is length times width equals the area. So in this case, we have 35 equals 9 minus 2x times 7 minus 2x. Okay, and so now we need to be able to expand this, bring the 35 over, and then solve it from there. So we get 35 equals 63 minus 18x minus 14x. Thank you, guys. Minus 14x plus 4x squared. And now I'm going to bring the 35 over. So minus 35 minus 35. We get 0 equals 4x squared minus 32x. 63 minus 35 is 28. Okay, and I can take out a common factor here. 4x squared minus 8x plus 7. That means we get 0 equals 4, x minus 7, x minus 1. So based off this, we get either x equals 7 or x equals 1. Now, in this case over here, we actually have to exclude one of these solutions. So algebraically, we've got two solutions, but if we look at this, like, is it possible for x to be 7 if this entire length here is going to be 7 as well? It's not, because if this is 7, this is 7, this is 14. But if this is only 7 from here to here, that's not going to work, okay? So we're going to exclude this solution over here, okay? Because it's not going to make sense in the context of this question over here. So for part A, the strip is 1 centimeter, okay? Part B, what are the dimensions of the rectangle? So if I put an x equals 1 into here and here, well, 7 minus 2 times 1 is 5 centimeters by 9 minus 2 times 1 is 7 centimeters. So this is going to be a 5 by 7 picture over there. Sound good? Okay, question page 232, question 20. The hypotenuse of a right triangle measures 29 centimeters. One leg is 1 centimeter shorter than the other. What are the lengths of the legs? So the idea over here, if we have a right triangle, we have ABC, so we can go, we can use Pythagorean theorem. We have a squared plus b squared equals c squared. So based off that, we have a squared is x squared plus b squared, which is x minus 1 squared, equals 29 squared, c squared, okay? So this is going to be x squared plus, now x minus 1 squared is x minus 1 times x minus 1 like this. And 29 squared, I'm just going to find some calculator, 29 squared is 841. So we get x squared plus, I'm going to multiply this out, we get x squared minus x plus 1. And I'm just going to subtract this 841 over here as well. So we get 2x squared minus 2x minus 840 equals 0. It's going to factor 2 out of this guy. Now this looks like a fairly nasty number, and it definitely is, but I think it's going to factor very nicely for us. So I think this is going to work as 2x minus 21 x plus 20, like that. So that means we get x equals 21, or we get x equals negative 20. Okay, so since the dimensions of a triangle over here, well, I mean, a negative length is not going to make sense. So we're going to exclude this solution over here. What are the lengths of the other legs? Okay, so this is going to be if x equals, so this is going to be 21, and this is going to be 21 minus 1, which is 20. So the legs, measure 21 centimeters and 20 centimeters. All right, so that's how this guy's going to work over here. Okay, page 254. So this is in the quadratic formula section now. To save materials, Choma decides to build a horse corral using the barn for one side. He has 30 meters of fencing and wants the corral to have an area of 100. What are the dimensions of the corral? So the thing is, this seems very similar to some of the other questions we're doing in the max min section of chapter 3, but in the other unit, we're asking you to maximize an area, but in this case, they're not asking you to maximize the area, but they're asking you what are the dimensions over here to be. Okay, so for over here, this is corral. I'm going to call this x, and this y. So here's my equation number 1. Well, we have x plus x, which is 2x, plus y equals 30. It's going to be the amount of material over here. Now our area is going to be 100, so our area equals x times y. So same thing with the last one. I'm just going to solve this equation, make it y equals 30 minus 2x, and plug that into here. And we also know that 100 is our area. So we have 100 equals x times 30 minus 2x. 100 equals 30x minus 2x squared. Okay, so now this is a regular quadratic. I'm just going to bring everything to one side. I'll bring this 2x squared over and the 30x over, so we have 2x squared minus 30x plus 100 equals 0. Guys, a good practice for a question like this is to always factor out something if you can. I'm going to take out a common factor of 2 out like this. This makes the number a little bit easier. So now I'm going to use my quadratic formula on this term right here, and this one over here. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So x equals negative 15 plus or minus square root of negative 15 squared minus 4 times 1 times 50 over 2 times 1. X equals 15. 15 squared is 225. 4 times 1 times 50 is 200 over 2. X equals 15 plus or minus root 225 minus 200 is 25. That's very nice. That means x equals 15 plus or minus 5 over 2. So 15 plus 5 is 20 divided by 2 is 10. 15 minus 5 is 10 divided by 2 is 5. Okay, so what are the dimensions of the corral? So that means x equals 10, so that means that we're at 10 centimeters, or sorry, 10 meters here, and that means this is 10 meters here, and 10 plus 10 is 20, and we have 30 altogether, so we know that this is going to be 10 meters as well. So 10 meters by 10 meters, okay? Or it could be, if x is 5 meters, 5 meters, 5 meters, and then 5 plus 5 is 10, and we have 30 altogether, that means this is 20 meters like this. So it's or 5 meters by 20 meters. Okay, so that's going to work as well. There's going to be kind of two different possible solutions we're going to have for this guy over here. All right, guys, I hope that these word problems make sense, and I know that questions like this will pop up on some of your quizzes and stuff like that, so I hope this helps as well. Talk soon.